Okay, welcome to the meeting. Let's see. What do we have? Let's talk about updates on projects. So where does each person stand on their... I think I chatted with both of you in Slack this week about different issues. So let's get an update. Who wants to go first?
There's some repair choices for me.
Oh.
It's just some drilling noise.
Oh, okay. Is Jesse there too? I didn't know the third person was in the window there.
Ziyi? Oh, sorry. Could it be that you have some reversers at your house?
Yes. I'll check it.
Okay. Okay.
No, but it hasn't disappeared. Right?
Yeah, that's better. Yeah. So who's the third person here?
Actually, not really. I'm still hearing something. I don't know.
Oh. I don't know what it is. Yeah, I don't hear anything.
Okay.
Okay.
Well, whatever. Now it's...
Alright. Yeah, welcome.
Yeah, so since Ziyi is now without microphone, I can start. I've done basically my simulation and like just physical world. You know, this week I was focusing on polishing that part so that it looks like adorable and nice for the persons on the conference, basically. What I've done there, I've posted you a pull request with this data export part, and also some stuffs like some other things a little bit. And after that, I've in the last 2 days or like today, I've been doing you know, this wall repulsion and fitness function.
Okay.
So basically, that was the problem. Like I just used a very straightforward formula for the fitness function that lets you calculate the area of a polygon based on its endpoints, on its corner points, right? On the coordinates. So I just type in the coordinates, and there's some formula, you know, pretty similar to the vector product of the vectors that lets you calculate the area of this polygon described by these points in 2D space, just in, I don't know, like in 2 for loops, or even in 1 for loop. So I've tried to use this first, but then I've discovered that this formula doesn't work for self-crossing polygons. So if we have some kind of, you know, some kind of butterfly polygon that intersects itself in the middle, once we will be unable to calculate the the true area of this polygon using this formula. So I had to restrict, like I have a bunch of ideas on that. Well, one could use a Bentley Ottoman algorithm to find the intersection points in the polygon having its corner coordinates. There is a formula, but it's of course, like, it takes time to implement. So just the easy workaround that I've took is to restrict the memory of, you know, of this polygon to be a triangle, basically. So only remember the last 3 steps. This way we can't, of course, get any self-intersecting polygons, right? Because triangles, they are not self-crossing, because, I mean, they have only 3 corners.
Yeah.
Right, and apart from that, I've been doing this what Ziyi actually suggested last time. Thank you, Ziyi. So instead of vehicles being repulsed from walls, I'm now transgressing them to the other side when they're driving against the wall. So, I mean, if they drive, for instance, to the right and get above the wall, so to say, I'm just, I let them appear from the left side and continue their movement.
So like kind of a toroidal world.
Sorry?
Oh, like a toroidal world. They used to use that in video games to have things go from like one side of the world to another.
Yeah, well, it was just a single option that's left because, you know, this wall repulsion idea, it got vehicles stuck because the objects are static, and like the wall repulsion is also kind of static, and so vehicles were just stuck against the wall, and they were basically doing nothing when they were driving against the wall, and they were just collecting themselves on the wall, and it looked just, you know, a little bit like not that professional, I would say, not at all scientific.
Yeah.
Yeah.
So that's not, I mean, that sounds good. The short part of that is that you fixed it. Like you fixed the problems that you were having. Correct? Like you don't have any more of the problems that you were having before.
Not right now, basically, no.
Okay. Well, that's good. I mean, you know, as long as you don't have any. I mean, you might still have problems that crop up, but I don't think. Well, I mean, I think it's probably a good working solution, so that's good.
Yeah, well, it's just
Yeah.
as usual in software developments, you have some runs of the simulation, you notice some bugs, and then you fix them and hope that it will work good. So
yeah, I guess that's.
Now it looks fine. I can show you if you want.
Yeah, sure. Let's do a demo.
Want to do it right now, or?
Yeah, we can do it right now.
Okay. Right. So I'm switching to my screen. There we go.
Okay.
Right, so yeah, I've added this data trace picker. Well, we can choose some directory here. For instance, like the default one is basically this one, data trace in the corner in the root directory of the simulation. Then the setting is just like to a bunch of objects and a bunch of vehicles, not that much, so that we can see what happens. And right, so we started, and now look, the vehicles are moving against. Oh yeah, first I've added more or less clear adjacency matrix visualization, so to say. So it's pretty challenging to do this with graphs. Like it also takes some time. I could work on this if we decide that it's really important for the presentation or demonstration of it. But you know, just adjacency matrix is also, of course, does its thing. So I can show that, you know, which neuron goes to which neuron and which weight does this connection have using adjacency matrix. And I've kind of implemented the way to print it properly so that it can be human readable and nicely understandable.
Right. Yeah.
At least as step in between. Yeah. All right. And so yeah. So for instance, this vehicle now, as you can see, or even these two vehicles now, they're kind of like switching from side to side. Well, it's pretty often occasion here that you know, as soon as they are switching from the right side to the left side, they are being kind of repulsed by all of these objects back to the right side, and then from the right side back to the left side.
Yeah.
I would say let's try to do more objects, because then we have less determinisms based on position, and maybe it it will look better. So last time I've done it with 20 objects and 20 vehicles, and it looks, well, decent. Alright.
Okay.
So here we go.
Oh wow. Yeah.
Yeah.
Yeah, so I can see how they come up to one side and then come up the other. That's that toroidal world feature where, you know, like if it goes to one end, it comes up on the other one. So it's almost like the world is sort of, a cylinder, and then you're only seeing the front of the cylinder. In the back of the cylinder, it's implied that the thing is going around the back and coming back out.
Yeah.
I wonder if it senses like one of the black dots on the edge of the world. If the vehicle comes up towards the edge of the world, does it sense the dot like over on this side? So like say it's on the left side and it's drifting off to the right side. Does it detect the dot that's almost right on the right boundary, or is it like something that...
You mean here, don't you?
Yeah.
Yeah, well, I mean, it's not exactly on the edge, so I guess it just repulses the vehicle back to the left side in this case.
Yeah.
So it's just as I've mentioned before, I've implemented Newton's law of repulsion, which states that repulsion is proportional to 1 through r squared. And in this case, the distance is very low. That's why this division through the distance is it results in a very big number, and vehicle gets repulsed back to the left side.
Yeah.
Yeah, I guess that's what's happening.
That brings up a quite interesting question. What is the standard physics? So you said there's a repulsion rate or repulsion area. I mean, if you made that stronger or weaker, would that have an effect on the world? And can you actually do that as a user? Or is that something that's set as a constant in the program?
So I mean, which repulsion rate, so to say, or repulsion? How strong should a repulsion be?
Well, I mean, is it like a constant, or is it something that you can modify in the simulation?
Exactly. So in the menu, how it looks now, you can. Just a sec. I will just run it once again. So there's this sub-menu of world objects, and here you can specify the minimum effect and the maximum effect of the object. And then the strength of repulsion that will be in a object will be decided on random basis between these two numbers.
Okay.
That's how it looks now.
Oh, okay. I see.
We can, of course, if you won't change it. I mean, I just didn't have any considerable thoughts or maybe like ideas where I would say that this idea implements nature or simulates nature really good. Right. That's why.
Right. Well, I mean, it's just, like we were talking about with the use cases. In the use cases, you might want to set up specific experiments in the environment. And so, depending on what people want. Sometimes you want to modify the physics because the physics, although they're usually constant, you might have a case where you'd like to see what happens if you modify physics so that they're not exactly the same. Like, I'm thinking in terms of like flocks. Are you familiar with flocking in birds? Where you have, birds kind of form flocks out of a bunch of birds, and then, how do they do this? How do they form these flocks? Well, as it turns out, people have modeled this process, and they found that each bird actually follows a very simple set of local rules, and the rules usually involve some sort of repulsion from its neighbor. So the birds have to do, each bird has to detect how far away it is from its neighbor, and then maintain that distance, depending on how the flock moves, and you end up with these collective behavioral structures. So, I mean, it is actually something that people might be interested in implementing as a way to sort of, reproduce that type of behavior.
Yeah, sure. I mean, I've also planned a, so to say, world object builder, or I mean, even world builder. There's some kind of interface where you can build the whole world with its object. Also specify how strong this object repels the vehicles and stuff like that. It's surely on my Trello board, which is the one thing that we have to decide is which priority it has and when do we want to implement that. Maybe we implement it before the conference, maybe we implement something else before the conference.
Yeah.
These are options to consider, of course.
I think, yeah, for the conference, I guess it depends on how you plan to present it during. So, like, I don't know how you're planning to do the demo. Are you planning to just run through a very quick example, and then kind of give some background on what was involved in building it, or what were you planning on doing for that?
Well, I was thinking of maybe showing my slides if I can.
Okay.
I will look into it and tell you more. I guess I will be able to, of course, show this presentation that we had in the beginning of the project. Maybe my final presentation that I'm going to present next week. When was it?
Yeah, we haven't scheduled it yet, but probably for you it would be useful before the conference because you can get the latest.
Yeah, totally. Yes. Yeah, and then I will just show the simulation process itself and maybe explain on what it is and where it is, and just let the users maybe run make some runs with different parameters.
Okay.
And yeah, I mean, I was also planning on maybe some use case. Maybe it's not that big, not that big use case, not a separate experiment that we would publish in some paper afterwards. I guess we don't really have much time for this, to do a really proper experiment with all the constants met and with all of the constraints, details throughout. But we can, I mean, just to showcase maybe some stuff that I will not just run the simulation and show, okay, this vehicles move and they have a physical space and that's kind of cool. And we also can evolve them. Yeah, that's really good. But we can also do additionally, we could do maybe answer some small scientific question. That would be, of course, really good, because then I would say, okay, look, we run the simulation, and then we want to have this or that question answered, and here it is. Why we use our simulation. So with these agents and this genetic algorithm, we kind of maybe go to some goal or purchase some. So we go after some scientific question and also try to solve it with a simulation. That was what I was referring to as use case. So kind of, not just a useless piece of software that's, well, that may be useful, but you don't really see how it's useful. So I would, of course, like that we also have some kind of this scientific question that I could at least mention that one could refer to with our simulation.
I think what might be useful is just to bring up the idea of use cases and say, what are the kinds of, just maybe bounce it back to the audience. What are the kinds of things that people are looking for? What kinds of experiments do people want to run in this? And then, maybe people will give examples, because there are always, experiments that might be very suitable for this platform, might be experiments that just aren't. And so it doesn't make sense to try to come up with use cases for things that aren't really practical. I think the spatial cognition thing you might mention a little bit in the presentation. Just like, okay, we're thinking about doing something related to spatial cognition, and then they'll tell you if that's they'll probably give you a lot of pointers. I think it'll probably be okay with people, but they'll give you a lot of extra information about like, oh yeah, I could see us doing it this way and that way, and so it'll stimulate discussion for sure. And I think that's what you want.
Yeah, surely. I mean, that's right. I just would maybe, to ignite their imagination about what one could do with the simulation. I would maybe bring some example. For instance, this use case example, like the special cognition one. I find it to be pretty intuitive and maybe also known to a wide audience of the fellow community. And then, yeah, I would do some kind of that. The also one idea I had, of course, is also what I've wrote you about maybe searching the motives that we've evolved in the mammal brains database that you've sent. So that could also be something that would bring us, I mean, maybe closer to people closer to believing us that we are doing some natural thing and really something that has to do with biology, at least slightly.
Yeah, so I mean,
but it's of course then connected to this NP-complete problem of finding subgraphs and graphs, and I mean we have a lot of graphs and all of these graphs that we are searching, and they're kind of big.
Yeah, that's the other problem too. And then, I don't know, like, I don't know what. Well, INCF is sort of computationally oriented, so people will have ideas for that too, because they're probably tools that can be used to mine the graphs. If you did this to like a biological audience or a neurobiological audience, they probably just think, well, that's pretty easy or that's impossible, But like with people with, computational background, they might say, oh yeah, there's this tool that you can use that's perfect for this. And then, but I think if you point out that, it generates a lot of data, basically. I mean, you generate a lot of graphs that are constructed. Then people have they can actually use it to match up with experiments or compare conditions between two different runs. So more classical simulation where you might have set up your environment two different ways and you run the experiments and then you mine the graphs for differences. And then of course there are tools that you can use for that, but that's something that it's probably beyond what you're doing here. I don't think it would make sense to develop anything new because the tools probably exist somewhere. But then the trick is to find good ones to do that next step.
Okay.
So I mean, all the those are things that you might want to mention. You might want to try to get feedback on.
Okay. Yeah.
Okay. Yeah, good job. So your the final project is, I think you can start submitting it this coming Monday, and I think you can submit it until the end of the week. So they're going to send out information about submissions, and then again, what we want to do, to end the program, is to get the entire thing. I guess what they do is they check. You go to a single URL that's static, so you can use a GitHub repo, you can use a gist repo to submit the link, and then they go to that link and everything is there. And if they basically what they'll do is I think they'll clone the repo, try to run the application, and it has to run.
Yeah.
So everything. I mean, this next week I think. Aside from working on your presentation, probably also go through technical bugs and anything that you think might be a problem, anything you want to clean up, documentation too. Just go over it and make sure that it's there in the right place so that they can get to it.
Yeah, I've also added as we've talked about that, I've added a Jupyter documentation to the repository now. Have you seen that?
Was it pull request or was it like
Yeah, it's in the new pull request. Should be.
this was today or the other day? Because I accepted one the other day.
Okay, I think it was in that.
Yeah, okay. Yeah, I think I saw it, yeah.
Yeah. Okay, so yeah, it's there now. So
Okay. Good.
I might add something there, of course, as well.
Yeah.
Let's just see.
Okay. Well, yeah. I mean, if you have any questions before you submit, let me know. You know, we'll go. I don't think we need to go over it. I mean, I think you can figure out whether it's going to run, but then let me know when you submit it. I think sometime next week, if I don't know when you're comfortable with submitting it. Obviously, I would recommend like maybe the day before the deadline, just so that
Yeah.
you know.
I think the day before the deadline is the best.
Yeah.
In my opinion. Yeah.
Good. Well, good work. Ziyi, do you have an update for us? Yeah, I looked at Ankit's code and that was inspiring. Well, that's good then. Okay. But for time matter, I went on to fix my code. I avoided the oscillation obsession with one stimulus source by identifying plateau and saw shapes in the preference. Okay. The oscillation is not completely avoided, but nearly. Also, I applied the ideal preference and ideal gustatory values. These 2 days, I am updating my GitHub page and documentation. Okay.
Dr. Alicia, I'm sorry, I think the drilling noise is coming from your microphone. Could it be?
Is it mine or?
I think so, because I'm still able to hear it even though the other ones are muted.
Well, let me mute and Z, do you want to talk a little bit about this and maybe do you have any demos or anything?
Yeah, sure. I'm gonna share my screen. So the yellow curve here is the ideal preference, and the yellow curve over here is the ideal stimulus. So there's a little bit difference between the ideal stimulus and the received stimulus. But it is pretty hard to show here. So just notice the white curve over here and the yellow curve over here. So there are a little bit difference because I used the mapping between the olfactory and gustatory stimulus, and there's a difference. Oops. And there's another problem over here. So there's a sec fault, which I don't know why. Seems like there's NNM values. So what I want to try to say is that even at the center of the stimulus source, there are values from other stimulus sources. So the actual association results might be a little bit different between how can I say it? Well, so for example, even when it is within the range of taste, that is, the taste is sensible, the olfactory value is not the pure values. There are for example, this tool, the smell is adding over here. So even when you are at this dot, right at this dot, you're not associating the two pure smell and taste. So that is why there's like the learner results is not like that great. But anyway, I think it is associating, right? Yeah. Okay.
Okay. Thanks.
Sorry, I think I didn't make it clear. Did you understand what I said?
I think so, yeah.
Mm-hmm.
So, yeah, you're fixing some of the features in there. You actually looked at MKIT's code and you were able to use some of it in there, or you were able to be inspired for making the changes. Or...
No, actually, I didn't use like any of his parts because his is kind of like a very different from mine.
Yeah.
So he used a sensory activation function, I think.
Oh, okay.
Yeah, and he used like a left or right sensor, and mine is like only one sensor. So that's one like very major difference. And so if you remember, like before when oscillation happens, there's like plateau, right? Or like saw. So I have this historical data, so if I can identify the saw shape or the plateau shape, then I can just avoid. So I can just like force the movement system to just move toward targets instead of like obsessing.
Yeah.
And also by like plotting the ideal statutory values, I found out that one reason that is like making the prediction worse is that even when it is at the center of the stimulus source, it is not associating the pure olfaction, the pure smell with the taste. Because even at the center of the stimulus source, there are smell from other stimulus sources. So it is like it is still associating like the noisy smell with the taste. So that's why there's like a little bit offset between the predicted values, like the red curve, and the real value, the white curve.
Okay. Did Jesse or Stefan have anything to add or any comments?
Yeah, it was just interesting for me. Could you maybe show once again the program?
Sure.
So I mean, yeah, maybe I can explain it also. There was like on the plot in the on the right plot, exactly on the plot.
This one.
In the left down corner.
This one.
Yeah, this one. There are two types of inputs. So the one is olfactory and the second is gustatory, I suppose.
Yes.
So the OG, yeah. Okay. All right, then I was guessing it's right. Yeah.
Okay.
Thank you.
So, Jesse said he doesn't have any additional comments. Good work. That's good. So I was wondering if Ziyi wanted to do a final presentation as well, because I think this would be useful. Remember, you did the first presentation on the project and you hadn't really started it yet, and now you've done a lot of work on it. So, yeah, why don't we schedule a final presentation sometime soon? It doesn't have to be like, it can be within the next couple of weeks. I don't want you to put a lot of time into it. Just take your old slides and basically, see what's changed, and then just add to that. Add a slide and remove slides as need be. So, and then we can, when you're ready, you can maybe send it to me, and then we can schedule it for the next couple weeks. So. because I think that this is good work. I'd like to see like a little bit more. I can see like an actual presentation of it though. That would be good. So that's good. I think we're coming up on the end of the actual formal GSOC program, but like I said in the newsletter, I'm going to be setting, if people want to work through fall, correspond, or, if maybe we'll have a group in the fall, that's fine. We'll set the times up for that. We'll just figure out who wants to do what and what times are available. So, and then I imagine everyone's got their schedules different for fall. I mean, whether you're going back to school or whether, whatever is going on, things will change up. So, any other comments? Did Ziyi or Jesse have any comments on Stefan's presentation or his demo?
Good luck.
Thank you.
Yeah, it looks good. So, yeah, good. No, it was good. Jesse said it was good.
Thank you, Jesse.
So, that's good. So, Stefan, I actually sent your letter for a request for funding to Malin. And, hopefully, I don't know how they're going to distribute it, but you're in the pool now, so.
Let's see.
Yeah. Okay, so let's go to the board. Let's see. Let me get the link. Chat. We go to the board here. Projects. That'll take you directly to the board. Otherwise, you go to the projects tab and you click on the board. Actually, let me share my screen. I found that that's actually easier for people to follow along. I don't know if that's my machine or not, but I hear it now. Okay, so let's see. We've got the in progress and to do. So I see Jesse has added a new issue here. Thank you. We'll convert this to an issue. And then we'll assign it to Jesse. Okay. And then we'll review in a minute. So let's do in progress first. So check Stefan's Trello board. That was for me. And I looked it over a little bit. I saw some of the things you had on there. So yeah, we'll have to maybe Slack about it. I'll look it over again and see if I have any questions. But I think these are pretty much consistent with what's on the board at this point. Just in terms of like, we're kind of reviewing the potential bugs in the code for the submission, and then getting ready for the GSOC conference, or I mean the INCF conference. Then create list of data export and persistence attributes. So this was something mainly that Stefan had talked about doing, but also Ziyi as well, just in terms of like being able to export data in tabular format. So I see actually that you showed me the thing where you have the adjacency matrices for the brains. That was for Stefan. That's good. So we'll keep that in progress. Respond to request for travel funding. That was number 44. I think we did that, and now we're just waiting for the response. Number 22, defining fitness function in the context of behavior. I think that was largely Stefan. He mentioned that in his presentation or his demo. What do you want to do with that issue? Hello?
Yeah, sorry. Was there a question?
Oh yeah, I asked you What did you want to do with issue number 22? Defining fitness function in the context of behavior.
Yeah, I guess it's well, it can be improved anytime. I mean,
Yeah.
that's the point with that.
Well, we'll just leave it in progress, I guess.
Okay,
Yeah.
it's fine.
Number 45, develop use cases and deploy. So that again is something for Stefan, but I think if Ziyi is interested in this, this might be useful too. So what we've been, Stefan and I have been talking about sort of in Slack is this idea of a use case. So a use case is like you think of like an experiment, like classic experiment, like say the Morris Water Maze, which is a spatial cognition experiment. It's something that people are familiar with in, say, like psychology or neuroscience. And it's something that you might set up in one of these environments. And then the trick is, like, you know, the idea would be you'd be able to select an experiment that would be pre-set up in that environment so that a user could just go in and run that experiment and they don't have to deal with setting it up. You know, it's like a template. But we're, you know, use case in this case I think is a little bit broader, thinking about maybe how people might use the simulation for what end, to what end.
Yeah.
So I mean, this is something I think Z wants to think about more too. I think it would be useful because if people want to, you know, use your software or, you know, whatever you want to do with it, I think that's like if a person from, you know, say like neuroscience comes to use it, you know, they might be interested in just running a pure simulation and playing around with it. But my guess is a lot of people are not going to be that interested in like trying to, you know, get the thing to run. They might want to actually see it, that it's useful for something that they're interested in. So, I mean, that's what this is all about, the use cases.
Yeah.
I think I might add you to it because I think we should talk about that as well.
Okay.
Yeah. And then we'll probably include Z in some of the conversation on that too because I think it will be useful. Then number 25, create a list of visualization tools and solutions. So again, I think we have that. Let's see, if I open that number 25 up, yeah, it's in the README in the repo. It's just a list of tools, and you feel free to add to it when you find something you like. I've added a lot of things we've already mentioned in the meeting. Research agent mapping, perception, representation, environmental space, and or resources, number 31, and that is Jesse. Do you have any more to say about that, or should we put that? Should we leave it in to do? Yeah. Okay, to do. So let's leave it there. Then find conference funding for a professional organization. So we mentioned that, and then we actually did do the INCF grant. But again, I have this link to a bunch of potential travel grants. If people are interested in, you know, traveling to present work, that's a good resource. Create presentation for INCF demo. That's for Stefan, and that's in progress. Maybe we can see, like, maybe you can send me like a draft version of it this week or maybe early next week, depending on when you want to do your final presentation. And then,
Right.
yeah, I mean, you know, I want you to focus on getting all the kinks worked out of the simulation first, but like then that would be the next priority. Deep dive into the ever good regulator theorem. That's Jesse. So we're still kind of in progress on that, but we've been talking about that, and you know, we'll be working on that. So that's in to do. Discuss relevant scientific questions. I actually added a channel to the Slack. It's called Research Questions. So I added Jesse. I'll add Z and Stefan to that list or that channel as well. it's just a place on Slack where if you come up with some interesting questions, even if they're not like formal research questions, but just things that you think might be interesting to know the answer to, and maybe we can answer with simulations. Put them in there and see. Maybe another person has a good idea of how to answer that. Let me stop sharing my screen for a minute. Okay, so I'm back. I think I got
Yeah, I think
suppressed. Yes.
it's this problem now.
He's still connecting.
Can you hear me well?
Yeah, I can hear you.
Okay, I can hear you well as well.
Yeah. I don't know if he's still spinning there. The wheel's still spinning. Connect. Let me share my screen again. Share. So let's go back to the figure out how it'll do back in. Well, let's see, what do we have here? Okay, yeah, I gotta find out from him about this next one. The dataset references, those are still being added to. Those are in the repo as well. So let's see. Let's move over to actually we're in progress. So we're in to do, and now I have a question for Jesse again. This is his new issue. List out scientific guiding research questions in the Slack channel. So we actually just discussed that. So there's a new Slack channel for that. And then I think these last two, number 29 and number 11, are old issues, but I'm leaving them in there because we don't know what we're going to do with those. So it's work on grammar and coding number 29 and review Holland's paradigm number 11. I think both of those were Stefan related, but also Jesse related. I think Stefan might have some ideas about that. Do you want to leave those in there? Or?
I would say if we can put this and done. I've reviewed that. I mean, well, yeah, I know what it's about. I can Google it if I need it.
Okay.
I don't know about you, Jesse. Are you fine with Holland steering? Do you know what it's about? Maybe I can.
Okay, that's fine.
Okay.
We'll just put it in done. Okay, I don't know if Jesse's going to be back, but I just had a couple questions. I guess the look over Ankit's solution to movement issues with code, I think that's done because he said that he had looked it over. So that's good. And then the other one was this develop ways to evaluate movement cues generated by the network. I think he's working on that or solved it. I can't tell. I wish you were able to come back, but so I think that's it for that board for right now. Are there any other issues you'd like to add to the board, or?
Not at the moment, no.
Okay, how about you, Jesse? Oh, there he is. Hi. There you go. Okay, Z, I have a question for you. I had the board open. Let me share my screen again. I have two issues I want to ask you about. So the first one is this number 47. Look over Ankit's solution to movement issues. So is that done, or is that something that you're still in progress?
Yes, that was done.
Okay. And then this number 27. Develop ways to evaluate movement of cues generated by network.
Actually, I didn't develop a way to evaluate the movement, but just evaluates like the preference and the predicted taste.
So this is something you just want to move to done, or?
Probably, because like I talked to you about, maybe I can do like use a chained Braitenberg vehicle and to creating new environments and to like evaluate movement over there, like doing animal experiences.
Yeah. Like you would train it and then.
I don't know if that's going to be effective or not.
So you would train it and put it in a new environment and evaluate.
Yeah, I'm thinking about if that is like that is appropriate to do. I don't know if my current like model is wrong.
I mean, it's something you could try. I think training it is, like you have development and then you have adulthood, right? Like development is basically training an organism on the environment, and then they get to interact with it. So that might be, it might be a way. If you want to do that, why don't we create maybe a possible issue here? So let's see.
Yeah.
We'll put that in as issue number. Let's see. I have to make it an issue. And now it is issue 51, and I'll leave it in to do, and then let me assign you to it. And I'll assign Ziyi to it, and then that'll be. And if you don't end up doing it, or then it doesn't end up well, then we'll just. You tried. We'll see. Then maybe that's not the best way to do it. But I think you might see some success because that's actually kind of a common strategy for people who do stuff with I think like some of the developmental robotics stuff. That's exactly what they try to do to see if their developmental program is effective. So we'll see. But that's good. So Jesse said that he didn't have any issues for the board, and so good. So thanks for meeting me on Friday instead of Saturday. I'm traveling tomorrow, so and I'll meet you next week. We'll meet on Saturday, so that'll be fine. So next week, probably Stefan will have some. I don't know if he wants to make a run on his presentation, but it's okay if you put it to the week after. Actually, we're coming up on the conference, so it might not be something that we can do in the whole group. But let me know before. We should make one dry run before you do the presentation.
Okay, yeah, sure. I will let you know. We have to do it before the Saturday after the next week then, because it's the 31st, and I'm on the 31st. I already have a workshop there in Warsaw.
Okay.
So we have to do it before the 31st of the August.
Yeah.
Yeah.
Okay. And then hopefully we'll have some comments, and it'll be. I'm sure you'll probably have a pretty good presentation already, but we want to do a dry run so that you get the slides and everything.
Of course.
Okay. So if there are no other questions, have a good week, and you can. Okay. See you later, Jesse. And Slack me if you need anything. Take care. Bye.
All right.
Okay.
Have a nice week, everybody, and until the next week then.
Yeah. See you later. Bye.
Bye-bye.
Have a nice week.
Yeah.
Bye.
Thank you.